You're looking at the Falcon 9 launch vehicle carrying the Dragon spacecraft for SpaceX's CRS-7 space station mission. It's Sunday morning at our launch pad at Space Launch Complex 40 at Cape Canaveral, Florida. I'm John Innsbrucker, the Falcon 9 product director. With me today is Brian Malstedt, a SpaceX integration and test engineer and one of the Dragon controllers for this mission. The Falcon 9 is currently counting down, and it is just under 19 minutes to launch. Liftoff is targeted for 10:21:12 a.m. Eastern Daylight Time, or 14 hours, 21 minutes, and 12 seconds Universal Time. Our launch window is instantaneous, lasting 1 second. This is typical for our flights to the International Space Station. The SpaceX team is working on no issues at the moment. It's been a very smooth countdown this morning. Now, should we need it, the backup launch window is tomorrow, the 29th of June, at 13 hours, 58 minutes, 37 seconds Universal Time. Brian, can you bring us up to speed on what's happened in the last day?
Sure, John. Falcon 9 rolled out to the pad Friday morning, the 26th of June. Dragon powered up and final cargo load began yesterday while the rocket was horizontal at about T-minus 23 hours. We raised the vehicle to vertical once our cargo load was completed and the capsule was closed for flight. This process took only 8 hours, our fastest yet. Streamlined cargo load and launch operations allow for time-sensitive science payloads to enter orbit more quickly, preserving freshness on their way to space. The Dragon vehicle integrity test commenced at about T-minus 9 hours, bringing us into initial configuration for launch and exercising all subsystems on the vehicle to ensure that they are fully ready for flight. Falcon propellant loading began at about T-minus 4 hours. Static fire in pre-launch for this flight was the most efficient propellant load in SpaceX history. Falcon 9 is now tanked and topped with liquid oxygen and kerosene propellants for today's launch. The Dragon spacecraft is ready for its ride to low Earth orbit. Autosequences took us into the final configuration for launch at T-minus 40 minutes. The Dragon team is now waiting for terminal count at T-minus 10 to initiate the final sequence before liftoff. So, all looks good on the vehicle end. How are Cape tracking systems and weather looking for launch, John?
Well, on the range side, the Air Force is ready to support with tracking and range safety systems, working no issues. On orbit, there are no collision avoidances that we have to worry about, so we'll be able to launch right on time at the opening of our window. And finally, the good news, as you can see on the screen, the weather is go for launch. This is both at ground level and upper altitude winds. The weather officer gives less than 1% probability of violating conditions. We're seeing good wind speed at the ground and at upper altitudes. Balloons show the vehicle is capable of flying through the atmosphere without issue. So currently we expect good weather through the countdown. Brian, let's talk about some of the features of today's mission.
Sure. This NASA mission will bring many different payloads to the International Space Station. Over 4,000 pounds of cargo are going up, including a portion to support more than 30 student research efforts from combustion and food growth in microgravity, all the way to meteors and astronaut health. Within Dragon's unpressurized cargo trunk is the International Docking Adapter, or IDA. IDA is the next generation adapter for vehicles to interface with the space station, standardizing how visiting spacecraft will dock with the ISS. The International Docking Adapter is crucial for our crew space program and will be used by Dragon 2, our next generation manned spacecraft. This adapter is also the first new American element of the ISS since 2011. Onboard CRS-7 is also Microsoft's HoloLens, which improves the task performance of astronauts on board the space station. Holo gives us the ability to project animations into the view of the astronauts, and Lens gives the ground a first-person perspective through the astronaut's eyes. These technologies allow near real-time communications with augmented reality. The spacecraft is additionally carrying a nitrogen-oxygen recharge system which will replenish breathing air for astronauts aboard the ISS. After CRS-7 has orbited with the space station for about a month, the pressure section of Dragon is planned to bring back over 1,400 pounds of return cargo. I am also very excited to announce that we are attempting another drone ship landing of the first stage this mission, with anomalies from previous attempts having been addressed. The autonomous spaceport is steady off of the East Coast, holding position with self-controlled thrusters, waiting for a rocket to re-enter our atmosphere and find it. So that's a little background on the highlights for this space mission. We're going to go back to John for an update on our status in the countdown now.
Thanks, Brian. Currently, the team is waiting for the beginning of terminal countdown. There will be a readiness poll that will bring you at T-minus 13 minutes. Currently, they're just looking at systems, making sure everything is ready to go before we turn it over to the ground and flight computers. Weather continues to be go, and the team continues to work. No issues on the launch vehicle and the Dragon spacecraft. You're looking right now at a view of Dragon on top of the Falcon 9. We're venting gaseous oxygen from the second stage as we continue the process of just topping off in preparation for final closeout of liquid oxygen loading that happens during the terminal countdown. We're going to listen in now as the SpaceX launch conductor polls the 13 members of the readiness team. And you'll see that and hear that coming up right now.
All stations verify, ready for launch. FTS.
FTS go.
Prop.
Prop go.
AVI.
AVI go.
GNC.
GNC go.
Ground.
Ground is go.
VC.
VC go.
GC.
GC go.
RC.
RC go.
OSM.
OSM go.
ROC.
Rock go.
CE.
Go.
MD.
MD is go.
LD, verify go to initiate terminal count.
LD is go to initiate terminal count.
Proceeding with terminal count and countdown master.
VC and DC start the terminal count auto sequence is set to start at T-minus 10 minutes.
Terminal count is set to run.
DC countdown net.
DCM.
You've heard the SpaceX team give their goes for entering the terminal countdown. We've added some features to the webcast video. You heard and saw the readiness poll on the display. We've also included the terminal countdown sequence and major events that occurred during it. That sequence begins at T-minus 10 minutes as the ground and Falcon 9 computers control the final events in the countdown, and the Dragon computers do the same on board the spacecraft. Immediately after T-minus 10 minutes, the pre-valves are open to the 9 first-stage engines, allowing fuel and liquid oxygen to flow to the inlet of the engine turbopumps. Bleed valves are open to allow the liquid oxygen to chill in the engines to prepare them for ignition just before T-minus 0.
Dragon will then transition from external auxiliary supplies to internal battery power at T-minus 8 minutes. Inside of 6 minutes, the transporter erector will begin to withdraw from the vehicle, a maneuver we call the strong back retract.
And then finally, in the last minute of the countdown, propellant tanks will be pressurized to flight pressures, and shortly before T-minus 0, the Falcon 9 flight computer will command ignition of the 9 Merlin 1B engines. After the flight computer verifies the engines are satisfactorily operating at full power, it commands the ground hold-down system to release Falcon 9 and Dragon for flight. Currently, the SpaceX launch conductor is instructing the team members on what to do during terminal countdown in the event of a hold. If we do encounter a hold, given today's instantaneous window, we will have to then recycle and attempt a launch possibly as early as tomorrow. With that, we're just under T-minus 10 minutes and 20 seconds. We're going to listen in now to the terminal countdown sequence that'll take us down to 0 and on into flight.
T-minus 10 minutes and counting on my mark. 3, 2, 1, mark. VC verified auto sequence has started.
Terminal count auto sequence has started.
GCVC standby on FireX.
Standing by.
Standing by.
LD start the tracking camera video recorders.
Started.
OSM set launch enable to flight.
Flight.
Stage 1 engine shelling in. Spin and T-tip final setups.
T minus 9 minutes. T minus 8 minutes.
Nitrogen ACS closeout. Stage 2 FTV motions. Stage 1 heaters closing out.
T minus 7 minutes.
Stage 2 heaters closing out. Vehicle switching to internal power. TVC bleed stage 2 has started.
T minus 6 minutes.
Tanks pressing for strong back retract. RP1 bleed stage 2 starting. RP1 bleed stage 1. Cradle movement.
T minus 5 minutes.
Cradle's fully opened. TVC motions on stage 2. Strong back motion.
T minus 4 minutes.
Stage 2 TVC motions complete. Tanks venting, post strong back retract. Toggle accumulator vent.
FTS is on internal power. FTS is armed.
GNC verify good. Stage 2 TVC motion.
GNC confirms good. Stage 2 TVC motion.
Lock load closing out. MVAC igniter purge has started.
Strongback fully retracted and pinned.
Stage 1 throttle valve setups. Stage 2 helium fill closeout.
LD verify go for launch.
This is the LD on countdown 1. SpaceX Falcon 9 and Dragon are go for launch.
Stage 1 tanks pressing for flight. Vehicles in self-align. TVC final setup. Stage 2 BTV check complete.
Range green.
Stage 1 helium fill closing out. Spin and stage step ISOs closed. Vehicles in manual. Vehicles in auto idle.
BC and DC verify F9 and Dragon are in startup.
F9 is in startup.
Dragon is in startup.
Stage 2 tanks pressing for flight. Flight computer has control of the vehicle.
T minus 30 seconds. T minus 20. T minus 15. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. We have liftoff of Falcon 9. Falcon 9 has cleared the tower.
Stage 1 propulsion is nominal.
Vehicles programming downrange.
Station is active.
Power and telemetry nominal.
T plus 1 minute. Altitude, speed 290 meters per second, downrange distance 1.1 kilometers. Vehicle supersonic.
Recovery drone ship has AOS.
Vehicles reach maximum aerodynamic pressure.
Stage 1 propulsion is still nominal.
Power and telemetry remain nominal.
Impact chill has begun.
T plus 2 minutes. Altitude 32 kilometers. Speed 1 kilometer per second. Downrange distance 13 kilometers.
Bragg, this is The Rock and CityNet.
Rock on the countdown net.
Well, this is John Isberger back at SpaceX broadcast headquarters in Hawthorne. We have lost the video from the vehicle. There was some type of anomaly during first stage flight. What we know is that the countdown was satisfactory. We did ignite the 9 Merlin engines. We successfully lifted off of the Slick 40 launch pad at Cape Canaveral. We proceeded through the stressing events during flight, went through maximum dynamic pressure, and went supersonic. However, it appears something did occur during first stage operations. SpaceX engineers will be reviewing the data in order to learn more about what happened during the Falcon 9 flight. One of the unique features of Falcon 9 is the large amounts of data that come on separate telemetry streams from the first and the second stage. This will bring an end to the live webcast for today. Please check our website, spacex.com, and our social media pages, where we will be providing you with more information as it becomes available. Thanks for joining us today.